Hello, so today I'm going to be talking about how mathematics relates to computing. So in mathematics, the surreal number system is totally ordered proper class containing the real numbers as well as infinite and infinitesimal numbers, respectively larger or smaller in absolute value than any positive real number. The surreals share many properties with the reals, including the usual arithmetic operation, addition, subtraction, multiplication, and addition. As such, they form an ordered field. If formulated in von Neumann-Bernese Gödel set theory, the the surreal numbers are a universal ordered field in the sense that all other ordered fields, such as rationals, the reals, the rational functions, the Levi-Civita field, the super real numbers, and the hyperreal numbers, can be realized as subfields of the surreals. The surreals also contain all transfinite ordinal numbers. The arithmetic on them is given by the natural operations. It has also been shown in von Neumann-Bernese Gödel set theory that the maximal class hyperreal field is isomorphic to the maximal class surreal field. In mathematics, an uncountable set or uncountably infinite set is an infinite set that contains too many elements to be countable. The uncountability of a set is closely related to its cardinal number. A set is uncountable if its cardinal number is larger than that of the set of all the natural numbers. In mathematics, topology, from the Greek words place, location, and study, is concerned with the properties of a geometric object that are preserved under continuous deformations such as stretching, twisting, crumpling, and bending. That is, without closing holes, opening holes, tearing, gluing, or passing through itself. Knot theory, a branch of topology, is used in biology to study the effects of certain enzymes in DNA. These enzymes cut, twist, and reconnect the DNA, causing knotting with observable effects such as lower electrophoresis. Topology is also used in evolutionary biology to represent the relationship between phenotype and genotype. Phenotype forms that appear quite different can be separated by only a few mutations depending on how genetic maps to phenotypic changes during development. In neuroscience, topological quantities like the Euler characteristics and Betti number have been used to measure the complexity of patterns of activity in neural networks. The main method used by topological data analysis is to 1. Replace a set of data points with a family of simplical complexes indexed by proximity parameter. 2. Analyze these topological complexes via algebraic topology, specifically via the theory of persistent homology. 3. Encode the persistent homology of a data set in the form of a parameterized version of a Betti number, which is called a barcode. Electrical and mechanical properties depend on the arrangement and network structures of molecules and elementary units in materials. The possible position of a robot can be described by a manifold called configuration space. In the area of motion planning, one finds paths between 2 points in configuration space. These paths represent a motion of the robot's joints and other parts into the desired pose. In mathematics, distributive properties of binary operation generalizes the distributive law, which asserts that the equality is always true in elemental algebra. For example, in elementary arithmetics, one says the multiplication distributes over addition. This basic property of number is part of the definition of most algebraic structures that have two operations called addition and multiplication, such as complex numbers, polynomials, matrices, rings, and fields. It is also encountered in Boolean algebra and mathematical logic, where each of the logical and logical denoted distributes over the other. In quantum physics, a quantum state is a mathematical entity that provides a probability distribution for the outcome of each possible measurement on a system. Knowledge of the quantum state, together with the rules for the system's evolution in time, exhausts all that can be predicted about the system's behavior. A mixture of quantum states is again a quantum state. Quantum states that cannot be written as a mixture of other states are called pure quantum states, while all other states are called mixed quantum states. A pure quantum state can be represented by a ray in Hilbert space over complex numbers, while mixed states are represented by density matrices, which are positive semi-definite operators that act on Hilbert spaces. So yeah, basically, I like just taking bits of information, which kind of like combine lots of different topics, because I know that at a more basic level of education, all the topics are very divided. But the complexity of mathematics, of physics, of computing really kind of shows how many possibilities we have out there purely by looking at how the language is turned into something very kind of complex and just very capable of understanding things in a very different way. So I really, really hope that in this century we kind of see more advancement become accessible to everyone, which I think at at this time and point, I'm not seeing it. So yeah. Anyway, as usual, hope you have an amazing day. And yeah.